The fracking fluids, once we pump them down, they stay down. So their toxic chemicals are not really what's causing most of our water contamination in fracking. But there is a serious problem with water contamination, and that comes from bad cement around casing. Remember that you had these choices of different companies that you could use to cement your casing in place. And the trial lawyers actually have a nice animation of what happens when you choose poorly. So they're looking here at this part of the drill here, the drill string, and there's the casing there. It's that steel stuff, and around the casing is a little layer of cement. And they say that when you have poorly constructed cement around there, there are all these little cracks and things around the edges. And what can happen is that methane and other naturally occurring gases can migrate through the outside of the casing, which is not what we want to have happen. It's called fugitive methane. And oftentimes this methane is actually in much shallower layers that's leaking up. It's not necessarily the methane from down deep that's traveling along there, but it does indeed travel up. It can get into aquifers and then dissolve in the aquifer and spread out and really contaminate the whole aquifer. This does happen because we know that water contaminated by methane, that was the single most common problem in our database from Earth Justice. That was what the problem was in Dimmock. That was what the problem was in the Divide Creek spill that we're going to look at in a few moments. That involved fugitive methane through bad cement. Likewise, explosions can happen when methane is getting into places it shouldn't, and that was our second most common reported incident in that Earth Justice database. You don't usually have failure all the way along the cement here. It's usually just little breaks in small spots. But if they're in the wrong places, bad things can happen. So let's say you have a shallow layer with methane in it. And this happens, there's all sorts of layers in the earth that have methane. The gas companies don't necessarily try and get all the gas out of those shallow ones because they may not have very much, but there's enough in there that it can cause contamination. So if there's a little bit of a break, normally, remember these rock layers are holding that methane down there, and they've been holding it down for a long time. But if the methane is able to migrate along the casing through that broken cement, it can start spreading out and escape and migrate upwards. So usually this is what's happening, is we see these shallow layers of methane where the casing cement becomes a real problem. Because if you have a problem in the casing down deep, there's so many other layers that are probably going to cap that off. So even if you have a little bit of a break, you're not going to have methane migrating up too much. And so you'll hear that a lot, is that there's evidence from isotopic information that shows that the methane was developed biogenically by little bacteria and things that live in the shallow areas, probably even shallower than I've drawn it on this particular diagram here. The good news is that you can actually inspect cement and fix problems. So you can send this special tool down. It kind of sends out a little radar-like signal, and you can plot here is an example where the cement is not very good. There's a little crack in this particular area, and so whatever layers that were right there are compromised, and so you no longer have a good seal. Stuff that's right below those layers can escape upwards. The good news is we can actually fix this. You know exactly where the problem is. The companies can go in and put extra cement in here to plug up these holes and prevent migration of nasty things in there.